Hello everyone, this is lab number 8. In this lab we're gonna study the digital controlled gain stage amplifier. So last time when we designed the amplifiers, we changed the gain by manually changing the resistors, but also it can be changed actually digitally, so we don't need to change every time by hand, like resistor, change resistor 1, resistor 2 and changing. We actually can change those resistor or change the gain like digitally. And for doing this we're going to use DAC or digital to analog converter, which use a bit pattern. So we have 12-bit digital to analog converter. It means that we have 12 zeros and ones. So by changing 0 and 1 we can actually change the bit pattern, and by changing the bit pattern we can actually adjust the gain of the amplifier. So go to your lab menu, go to chapter 13, find experiment number 13, the design of digital controlled gain stage amplifier, and please follow this instructions. So what you have to do, you have to connect two op-amps and your digital to analog converter as seen in this figure 13.1. And so what you have to connect first op-amp with two non-inverting input resistor R1. Choose R1 as 1K and choose R2 as 2K. It says it should be like in 2.2, so nearest to 2.2 what I can get if we use resistor R2 2K and resistor R1 is 1K. So use R1K to 1K and R2 is 2K. So connect the non-inverting input to resistor 1K. So from here you're gonna have the input. Then connect this feedback resistor R2 2K to the output of the second op-amp. In the feedback of the second op-amp you should have capacitor. Choose the smallest capacitor we have. It should be this gray one. And here in the DAC, so pay attention here. So here we have a DAC, digital analog converter. Basically we have two of them. They are just similar ones. Use like near one, the both one, so it'll be like easy to actually wire them. So here in the DAC you're gonna see like different outputs. So it's like FRF, then you're gonna have RFB, IoT1 and IOut2. So IOut1 should go like as it is written here. Current out1 should go to negative input of second op-amp, and IOut2 should go to the positive one. And don't forget to connect the plus to ground, and here minus negative input to the ground as well. Okay, ground here of the DAC is already connected to the ground, and the VDD already is connected to the power supply. Okay, and our feedback should goes back to the output of the second op-amp. So let's have a look of connections. So you connect 2K resistor. So first of all, connect 1K resistor to the signal generator. So 1K to the signal generator. 2K goes to the output of the second op-amp. This purple wire. Then here on the second op-amp, in the first op-amp, you don't forget connect negative output to the ground. Then here you're gonna have, as it's written here, capacitor from negative to output. So connect this gray line from the gray capacitor to output of negative output. Connect plus to the ground. So plus goes to the ground. This plus goes to the ground. Connect those two outputs to minus and positive. So IOut1 goes to the negative and IOut2 goes to the positive. All right, and RFB, the orange line, goes to output of this op-amp, the second op-amp. Okay, so once you connect everything like this in this schematic, set up your input signal as 100 Hz, 100 volt peak to peak, switch on, put supply of 10 volt, and initial connection you're gonna have this square wave output, so it's good sign of that your op-amp actually oversaturated. So it happened because your DAC is set to everything to 0. Okay, so your goal is to have this pattern, beat patterns. First change one, then second one, third one, and so on. Okay, so let's see. I'm gonna show as example what you should look like output. So change. Let's say, so what you have to do, you have to change manually these DACs. So you can use your hand, or you can use any tool you have, but be careful, don't break it all the way. Once you change, press latch data. So press latch data, and as you can see, we have the smallest output. Basically, the 11000, it means this. It means, so we have 12 digits from if you go from right to left, so it comes from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and this one is gonna have 11 position. So to the power 11 is gonna have 2048. So 4096 divided by 2048 is gonna be equal to, so this part is gonna be 2 by 2, and we in, so we're gonna have gain of 4. Okay, if we're gonna have second one, which position is 10 now, it was 11, 10, 9, 8, and so on. So for 10, 2000 to the power of 10 is 1024. So if we divide by this, it's going to be 4. So this is going to be 4 times 2, so again is 8, and so on. So you have to try it all possible patterns, at least for single ones, and calculate according to this formula and compare to this experimental result. Okay, and record everything in the table.